Today we will be talking about two software processes, a waterfall process and an iterative process. To illustrate these two, we will be building a bridge. So you've seen pictures of arch bridges, right?
Yes.
Mm-hmm.
This is exactly what we will be building. Your arch bridges will need to span across this river. So the idea is that your bridge is going to go like this. It doesn't have to touch the surface of the land here. As long as it spans the entire breadth of the river, this is what I'm looking for. Other requirements for the bridge that I have is that it must be an arch bridge, as I mentioned. I want to have exactly 3 arches. And those arches must be symmetrical. Because there are 3 arches, so the left arch and the right arch must be symmetrical to each other. Try to be economical. These bricks cost a lot. Try to use as few bricks as possible. We're going to start with the waterfall method. You will have 1 minute to design the bridge, and after that you will have 9 minutes to finish the construction. Okay, off you go. Okay, now that you have your designs, it's time to start building. Try to be as close to your designs as possible, but of course we have to keep in mind that this is Lego. You cannot make a perfect curve out of this, so perhaps think of this as a pixelated curve. This is what your arch is going to look like. Okay, 9 minutes. I see 2 beautiful bridges. Do you guys think they conform to your designs? Do they look like your designs?
Mm-hmm.
Yes.
So let's try to also make sure that they meet the original specifications. So they have to be symmetrical, and seems like they are. They have to have 3 arches. They have to be built economically, which I think this one is fine, but that one looks, I hate to say it, but wasteful. Look at how many bricks you've used here to build this arch. I think you probably could have used, well, maybe this arch could have been narrower. I don't know if you really need to have this much support for the surface that you built. But the most important test is going to come from these 2 vehicles, which we're going to try to run over the bridge. Over here, I think that the bridge is definitely too narrow. It's barely, well, actually, no, not barely. It does not support this vehicle at all. It doesn't fit there. It's going to, unfortunately, fall off of it. You see the problem, right?
Mm-hmm. Yep.
With this one vehicle definitely is going to pass through, but just in one direction. What about the traffic going in the opposite direction, especially if there is a heavy machinery like this? There is no way how they can pass. So I think that's definitely a problem. How would you go about solving these problems that we've identified? You guys, your team. So your biggest problem was that the bridge is just not wide enough.
Mm-hmm.
How would you fix that?
In order, I believe, to keep the minimal amount of bricks in the project, we could make it a lower bridge and wider. And I think that would solve our problem here.
Do you think it's possible to make this one a bit lower, though?
I think taking 1 brick off the bottom of each column.
But hold on a second. You said you have to make it lower. Why do you have to make it lower?
Well, that would
Less bricks.
Less bricks.
Okay.
If you didn't want to go the less bricks route, then we could just duplicate what we already have and just widen it by, this is 4 and I think this is 16 total, so we could do 4 of these and just put them in a row so there'd be 2 lanes both ways.
Even then, it would be very cramped when 2 cars tried to pass. So we might even have to make it, 10 wide, perhaps, maybe even 12.
I'm sure there are solutions out there.
Mm-hmm.
But it sounds like whichever solution you pick is going to require a considerable amount of time spent to redesign and then to rebuild the bridge. Maybe not entirely, but in a significant portion.
Mm-hmm.
What about this guy? What about this bridge here? The biggest problem with it was just wasteful construction, if you will. How would you change this?
We can take out from the sides here and then use that in order to maybe widen the bridge.
Would you have to disassemble the entire bridge?
Only the ends of it.
Only the ends.
Yeah.
But if you were to rebuild these parts, you would have to remove probably this many bricks from
Yeah.
here. and then rebuild them somehow.
Yeah.
Also think about another perspective. Your bridge is, I mean, the pillars, they are of the same width as they are at the top. Maybe you could also save a certain number of bricks by building your pillars in such a way that they're narrower at the bottom. This will give you a substantial amount of savings in terms of how many bricks you're going to use. So if you were to do that, how much of work do you think you could save if you were to rebuild this bridge? Would you have to completely disassemble it?
It sounds like you might have to completely disassemble it, yeah, because it's just too much of it on the bottom, and some bricks honestly are used for support, I guess. So it's best to take it apart and do it from scratch.
Yeah, we can't reach the bottom without taking off the top.
Exactly. So you have to completely undo the entire construction process and start all over again, not to mention that you probably need to go back to your original design and make some changes there. And in your team, with your construction, probably the amount of changes is not going to be as drastic as to completely redesign the bridge, but still, it sounds like you would have to remove the top surface of the bridge and rebuild that part at the minimum. Which, who knows, maybe would lead to other problems. Not that we're trying to create more problems here. We're going to build the same bridge, but differently. We will follow the same constraints, the same requirements. However, now we'll do it following an iterative process. We'll do 3 iterations. During the first iteration, I would like you to build just the foundations, just the pillars themselves, the parts that do not arch. In the second iteration, you will continue building and finish the arches. So finish the curvy parts. At the last iteration, you'll build the surface of the bridge. We'll start with the overall design. Feel free to use the same designs as what you created for the previous part. If you would like to draw something new, by all means, you can do that. But perhaps at the moment, you may want to take a look at your previous designs, see if you like them, if you don't like them. But let's take 1 minute. Let's take 1 minute to finalize the design. Again, you can reuse the old ones, or you can start the new ones. But I would like both of your teams to come up with an overall design for this bridge. You have 1 minute for that. So we have 2 sets of ongoing construction projects that represent two starts of bridges. Pillars here and pillars there. In many ways, they're similar. So let's see whether they're going to pass the tests that we're about to run here. So this is a bridge, right? It's not only for traffic that goes over the river, but it's also for the traffic that goes along the river. So I have 2 boats here, and let's start with the small one is important, but I think it's more important to make sure that the big one passes. And sadly, I don't think it will. So it looks like this bridge will have exactly the same problem. There is no way how this boat will be able to pass under the bridge. Here is the question. How would you resolve this problem?
You can.
I'd just say maybe we could widen the center arch.
This would seem like a very, very simple and the most obvious solution, probably. I think you can do the same thing exactly.
Wouldn't that make the arches so they weren't symmetrical?
But they will be symmetrical. Think about it, because there are 3 arches.
Size.
The axis of symmetry is going to go around here. So it's about this arch being the same as that arch. Mm-hmm. All 3 of them do not have to be of the same size.
Okay.
Just the leftmost and the rightmost have to be the same size to make them symmetrical.
Okay.
Now we're about to start the second iteration. At the second iteration, you need to finish building your arches. But before you do that, you need to address any kind of problems identified at the previous iteration, which again, hopefully will not be very, very difficult. So, you understand what you need to do at the second iteration?
Mm-hmm.
You're fixing the problems from the first one by adjusting the pillars. These pillars, you probably want to move them a little bit farther away. Here is a boat, if you want to apply the same test that I did. And then you will need to finish your arches. Any questions? 3 minutes. So let's see what we have at the end of the second iteration. It seems like we have a completed set of arches here, and over here we have one side that's been completed, and the other one, I'm guessing your team ran slightly out of time. Okay, but at least one side here, it definitely gives a good idea about the outline of the bridge. So first of all, let's see if the previous test passes. So here we have our boat, which passes very nicely under your bridge. And you guys, okay, so the previous problems have been addressed. But let's see, boats usually don't travel empty. Usually there's some load on the boats. So perhaps this piece of heavy machinery here. Makes sense, right? Mm-hmm. Okay, so is it going to pass? Yes, indeed, it passes. So the only outstanding issue that you're going to carry over to the third iteration is to finish this arch. But the profile is such that that it meets our test here. All right, let's see about you guys. I have a bad feeling here, because if we try to navigate our boat, well, you see what happens here.
I think it'll still be able to pass
You
through.
think so?
Kind of like align it perfectly.
Well, obviously, I'm not the best boat driver out there. So you guys proved me wrong. It seems like your bridge actually passes all of my tests. Very nice. So, you know what we're doing at our third iteration?
Finishing the
off the
top.
surface.
for cars to drive over.
Finishing the top of the bridge, creating the surface upon which we can run our traffic. Any questions? Okay. You have 3 minutes. So our third iteration is over, and let's see, we have two beautiful bridges. This one looks interesting. You guys want to explain what this is? Especially this feature here right in the center?
This allows two cars to pass each other in the form of a roundabout. Earlier, one of the constraints that caused our waterfall-style bridges to fail was that two cars cannot pass each other. But in this one, when two cars approach, this is a roundabout on the bridge. There are two stop signs.
Can you
It
show
should
me?
be generous.
So if we had one car coming this way and one coming this way, they would pass each other like so.
Oh, very nice, very nice. And let's see, did you have to redesign anything below it?
I
Not for the
don't know.
roundabout.
Not for the
No, we
roundabout.
just added the platforms on top.
Oh, I see. I think maybe you did not notice this, but I think you removed one of the pieces that was actually in place of this big plate. One of the longer bricks, perhaps the one like this, that was actually connecting these two
Oh.
arches over here, which is perfectly fine. I guess what you did is you made an on-the-spot redesign decision to accommodate these this solution here with this big platform on the top serving as a roundabout. Bottom line is you were able to accomplish your tasks of building a bridge within the allotted amount of time, and it seems like the bridge passes all the tests, right? Does the boat still pass under the bridge
Should.
Yes, sir.
with the car or this whatever this thing is?
It should.
It sure does. Amazing. All right, amazing job, guys. Okay, let's take a look at this bridge. It's not as wide as that one.
No, it is not.
It's not, but at least one car will, because I remember the biggest problem with with the bridge that you built was that it was a bit narrow, and even a single car couldn't pass it. So with some limitations in the sense that two cars cannot pass the bridge simultaneously, even though this bridge allows for more flexibility for traffic, it allows two cars to cross the bridge at the same time. Your bridge doesn't allow that, but nevertheless, it's very, very comfortable for a single car to cross the river over the bridge. So I think this still is very much a passable bridge. So congratulations, your solution, I think, passes all the tests. Very well, congratulations. So we looked at two processes, Waterfall and Iterative. Which one do you think allowed you to build a better solution, and why?
Well, the iterative, I think, definitely allowed for a less overwhelming way to tackle a problem, especially if you run into problems along the way. You don't have to go back to step one. Since you're doing it in steps, it's easier to address problems as you go on.
And the problems did arise. And it seems like you were able to successfully address them, even though at one of the iterations you ran out of time and weren't. Any other observations?
Yeah, no, I think the iterative process is good for more complex tasks because it allows for more flexibility as you work. But if you had, a simpler task, maybe less constraints, maybe you only wanted one car to pass, perhaps, then maybe the waterfall process could prove to be just as effective, even though it doesn't allow for as much flexibility when you're going back to correct your mistakes.
So in other words, if the requirements were simple, if they were stated very clearly from the very beginning, if there was no way for any kind of requirements, any new tests to emerge as you're developing, then Waterfall would not be so limiting for the process.
Well, I believe in the iterative approach, we were able to focus our attention onto smaller tasks, and adding all the smaller tasks together resulted in the final product of our bridge. Whereas in the waterfall process, we had so much to do, even though the chunk of time was proportionally bigger, it was just too much to focus on at once, and we weren't really able to process our thoughts completely.
That's a good point. That's a very good point. Okay, so I think all the feedback that you provided about your thoughts, your reflection about the differences between the two processes that we applied here to build in the bridge, they're pretty much covering all the most important aspects as they apply not just to building bridges but also to software processes. So thank you everybody for playing.